Hi everyone. In this video, we're going to take a look at question 1 from Midterm 1 of the Spring 2021, that was a lot of ones, offering of DSC 40A. Let's get into it. So in this question, we're given some function r of h, looks like this, and we're told that we want to use the gradient descent algorithm by hand on this function to try and minimize it. And we're given an initial prediction, h naught, and we're given a learning rate or step size alpha of 2 times the square root of 2. And we need to figure out what the next two guesses of the minimizing value are by hand. So before we get into it, let's start by recapping the gradient descent algorithm. So the way gradient descent works is it iteratively improves on our guess for what the minimizing input to our function r of h is going to be. And the way it does that is it starts, or it takes our current guess, h of I minus 1, and from it, it moves closer to the minimum, or it tries to move closer to the minimum, by moving opposite the direction of the slope. And specifically what it does is it multiplies the slope at the current point, or the derivative at the current point, that's what this is, by our learning rate, alpha. And so we can use this formula directly. When we're starting off, we know that h naught is 2. We're given that in the question. And we're also told that alpha is 2 times the square root of 2. So we're almost there, but we don't know what this piece is, right? We don't know what the derivative of r of h is with respect to h evaluated at our previous guess, which here is h naught, or 2. So what I need to do is determine the derivative of r of h. And again, I'm told what r of h is. It's this thing, h minus 3 quantity squared plus 1 raised to the exponent 1/2. So I can use the power rule to take its derivative. So this becomes 1/2 times h minus 3 quantity squared plus 1, now raised to the exponent minus 1/2. All of this has to be multiplied by the derivative of whatever's inside here with respect to h. And in this case, that's 2 times h minus 3. Now I can simplify this. Notice this 2 on the denominator and this 2 on the numerator cancel out. And so I'm left with h minus 3, all divided by all over the square root of h minus 3 quantity squared plus 1. How did this get on the denominator? Well, there's a negative exponent here. And why are we taking the square root? Well, we have exponent 1/2. Okay, so now we have a formula that will help us calculate the derivative of r of h at any point. So now let's try and use this in our particular formula, or in our particular case, I should say. So here we're looking for h1. We know that that's h naught minus alpha times this derivative evaluated at h naught. In our case, we're told h naught is 2, alpha, I don't know, I can move this. Alpha is 2 times the square root of 2, and this derivative evaluated at 2, well, I just need to plug in 2 into this formula right here. So that would have me calculate 2 minus 3 on the numerator, all over 2 minus 3 quantity squared plus 1. So let's do some math and see what we get. So I have 2 minus 2 root 2 over negative 1. On the denominator here, I have 2 minus 3, that's negative 1. I square that, I get positive 1. And I add 1 to that, and I get 2. So I have a square root 2 on the denominator as well. That actually makes it pretty convenient because these two square roots of 2 cancel out. And I'm left with 2 minus 2 times negative 1. So this ends up being 2 plus 2, which is 4. Great. So h1 is 4. Now what I need to do is repeat this calculation again to find h2. So similarly, I know h2 is going to be h1 minus my step size times the derivative of r of h evaluated at my previous guess, which was h1 now. Plugging in all the values I know, well, I know h1 is 4. I know alpha is 2 times the square root of 2. And now I need to plug in 4 into this equation that I have right here, or into this expression, I should say. So that gives me 4 minus 3 over the square root of 4 minus 3 squared plus 1. And again, doing some simplification, I have 1 on the numerator and root 2 on the denominator. These cancel out, and I'm left with 4 minus 2, which is 2. So my final answer to the first part, which is just asking for what h1 and h2 are, is that h1 is equal to 4, h2 is equal to 2. Great. So now if we scroll back up to the question, part B was asking us, with more iterations, will we eventually converge to the minimizer? And so the answer to that is no. And here's why. Notice when I started off with an initial guess of 2, I then went to an updated guess of 4. And then when I started off with a guess of 4, my next guess was 2. And since the only thing that gradient descent depends on is the previous guess and the derivative at the previous guess, it turns out that my next guess after 2 is going to be 4. And then my next guess after 4 is going to be 2 again, and so on and so forth. And so, gradient descent in this case is going to keep bouncing back and forth between guessing 2 as the minimizer and 4 as the minimizer. But neither of those are the true minimizer, right? If we look at the function we're trying to minimize, it's not an x, it should be an h. We know that the argument to a square root function has to be non-negative. And in fact, one of the pieces in here is something squared. And the lowest possible value of that is 0. Right? So the way to actually minimize this function is by making h minus 3 squared 0, which tells us that this function is minimized when h is equal to 3. But gradient descent keeps guessing 2 and then 4, and then 2 and then 4. So in this case, it doesn't matter how many iterations we have, gradient descent will not converge. That's not fun. That was question 1.